Hey guys, welcome back. This is Mr. Paredes, and today's assignment is Module 7, Lesson 2, Add, Subtract, and Factor Linear Expressions with Rational Coefficients. All right, this is in the Into Math 7th grade workbook, pages 229 through 236. This video will cover the Build Understanding and Step It Out section, task 1 through 4, on pages 230 through 232. So let's go ahead and get started. All right, so let's look at task 1 on page 230. A yard is shaped like an irregular quadrilateral with the side lengths shown. We have 2y plus 4, 4y plus 1, 1/2 y plus 6, and 3y minus 2. Part A. Write an expression that shows the perimeter of the yard as the sum of the lengths of its sides. Now remember, when we find a perimeter of something, we're finding the length around, or the measurement around that object, right? So the perimeter for this would be adding up all of these together. So I have 2y plus 4 plus 4y plus 1 plus 1/2 y plus 6 plus 3y minus 2. Part B. Rewrite the expression as addition of terms. So really, all they want us to do is rewrite this without the parentheses, right? And I have plus 4y plus 1. And remember, when you're doing this, you're really distributing that positive sign, right, that plus, into each one, each term inside the parentheses, okay? Plus 3y, and we'll have plus a negative 2, okay? Now you can write it as this, or you could just have it as what is a positive times a negative, which is negative, and you could have that written on the end if you choose to as well, okay? Part C. Use the commutative property of addition and the associative property of addition to rearrange the terms so that all of the y terms are together and all of the integer terms are together. So essentially, I want to get my y terms and put those together. So I'm going to have 2y plus 4y plus 1/2 y plus 3y. Now I'm going to take the next terms, right, which was plus 4 plus 1 plus 6 and plus negative 2. And like I said, you could have it as minus 2 on there if you want to as well. So part D, how can you identify like terms in an expression? Like terms have the same variable, right? So in our example, we have 2y, 4y, 1/2 y, and 3y. Those are the only ones that have variables, and they're all the exact same variable of just y. So for part E, simplify the expression by combining like terms. Well, the like terms, like I said, 2y, 4y, 1/2 y, and 3y. Those are all like terms. 4 plus 1 plus 6 plus negative 2 are also their own like terms of just integers. So now I want to combine those. So when I go 2y plus 4y and I'm going to add 1/2 y and 3y. Okay. 2 plus 4 would give me 6y. Down here, 1/2 plus 3 would give me 3 and 1/2 y. So I add those together. 6y plus 3 and 1/2 y, and that would give me 9 and 1/2 y. So I know from combining the like terms of the y's, I get 9 and 1/2 y. Now for the other ones, I want to go 4 plus 1 plus 6 minus 2, right? Or plus -2, however you want to look at it. 4 plus 1 is just 5. And I'll have plus 6 minus 2. This is going to give me 11 minus 2. And 11 minus 2 is just 9. And it's a positive 9, so plus 9. So that is how we simplify the expression down by combining all our like terms. For part F, show how you used the distributive property to combine the y terms. Okay? Now, really what we're looking at is just taking these coefficients which are the numbers in front of the variable. So I have 2 plus 4 plus 1/2 plus 3, and I have y on the outside, right? Because we're going to multiply whatever we get inside the parentheses to y. And like we did up here, when I added up my 2, 4, 1/2, and 3, we ended up with 9 and 1/2, and it's times y. All right, so let's look at task 2 on page 231. A path in a park forms the shape of an equilateral triangle with the side lengths shown. Okay, so we have one side length of 7.2d minus 4. An equilateral triangle means each side has the same measurement. So that means this side would also be 7.2d minus 4, and this one would also be 7.2d minus 4. So let's go ahead and look at part A. Write an expression that represents the length of the path as a sum of the lengths of the three sides. So we're going to add them all together, right? Each side. So I have 7.2d minus 4 plus 7.2d minus 4 plus, of course, 7.2d minus 4. Part B. Use the commutative and associative properties of addition to reorder and group like terms in your expression from part A. Then combine like terms to simplify the expression. So, again, we get rid of our parentheses, right? And we'll have just 7.2d minus 4 3 times, right? Now, what it's saying is to combine all of our like terms. Well, I know from looking at it, I have my terms that have the variable, and I have terms that are just integers, right? So I want to combine those together. So I would have 7.2d plus 7.2d plus 7.2, whoops. So those are just my like terms with the variables. Now I also have to do my other ones, right, which was -4 plus -4 plus -4. Okay? Now, when I combine all of what's inside, 7.2 plus 7.2 would give me 14.4, plus another 7.2 would give me 21.6 times D. When I combine my like terms inside the second set of parentheses, it's -4 plus -4 plus -4. All of my 4s are negative. They're all the same sign of a negative sign. So we want to add them all together and keep that sign. So I know it's going to be minus, and 4 plus 4 plus 4, or 3 4s, would give me 12. And I don't like this minus sign, so I'm going to redo it. All right, so we end up with an expression of 21.6 times D, or 21.6D, minus 12. Part C. Write an equivalent expression for the length of the path using the factor 3 and the length of one side. Well, I know there are 3 sides and they all have the same measurement, which was 7.2D minus 4. So let's look at part D. Use the distributive property to expand the expression from part C and then simplify it. So again, all that means is I'm just going to use this expression down for this one. I have 3 times 7.2D minus 4. Okay? Now, I'm going to use my distributive property, which means I'm going to take 3 and multiply it to 7.2D, and then multiply 3 times -4. So let's go ahead and rewrite that over here to the right. So I have 3 times 7.2D plus 3 times -4. Well, when I multiply those, 3 times 7.2D would give me 21.6D, and 3 times -4 would give me -12. Remember, positive times a negative is a negative. So when I combine those, I have 21.6D minus 12. And there would be my expression using distributive property. So let's look at task 3 on page 231. Another path in the park goes around a square playground. The length of the entire path can be represented by the expression 20x plus 8. Part A. Find an expression that represents the length of each side of the square. Complete the expressions on the diagram. So I know when I add up all 4 of these sides, I will get 20x plus 8. So that means if I factor it by 4 or divide it by 4, I can figure out what each side is. Now, the reason I'm able to do that and divide by one simple number of 4, or each side, is because it's a square. Remember, a square is only a square by definition if it has 4 equal sides. Okay? So, if I were to divide each one of these by 4, 20x divided by 4 would give me 5x. 8 divided by 4 would give me 2. So that means each side is 5x plus 2. Now, I can check this, of course, if I go 5 plus 5 is 10, plus another 5 is 15, plus the fourth 5 would be 20x, right? That would be 20. 4 2's would give me 8. So those definitely equal 20x plus 8. Part B, complete the equivalent expression for the length of the path, 20x plus 8. So in this one, we're factoring it out, right? We have a 4 on the outside because there's 4 sides, and each side is 5x plus 2. Okay? This is factoring. This right here would be the factor of 20x plus 8, right? Because for 20x plus 8, if I factor out a 4, 20 divided by 4 is 5x, or 20x divided by 4 is 5x, plus 8 divided by 4 is 2, right? These are equivalent to each other. So when they ask you to factor the expression, you're going to go from this to this. Find what number goes into both of those terms equally. For 20 and 8, 4 would be your greatest common factor, your GCF. So you would be able to pull 4 out of both 20x and 8. Okay, so in these assignments that you're going to be doing this week, when they ask you to factor an expression, that's what they are talking about. Okay, we're going from 20x plus 8 to 4 times 5x plus 2. All right, so let's look at the final task on page 232. Number 4, apply what you have learned about adding, subtracting, factoring, and expanding linear expressions to simplify the expressions. So part A, simplify negative t minus 5 plus negative t plus 3, right? And those two sets are in parentheses. So we want to rewrite it as an addition of the terms, right? So I have negative t plus a negative 5 plus negative 2t plus 3. Okay? Now we want to combine our like terms. The like terms would be my variables, right? I had a variable of t, and there's a negative t and a negative 2t. So I can combine both of those to get negative 3t, right? Negative 1 minus negative, or plus negative 2, we combine them, we get more negative. So negative 3t. Plus, I have my integers by themselves, right? Those are my other two terms, negative 5 and positive 3. So when I combine those, essentially it's 3 minus 5, which would give me a negative 2. Now, I'm going to rewrite this on the bottom. I have negative 3t minus 2, because I don't need the plus in there, right? I don't need plus and negative. I can just go minus 2. Part B, we want to simplify this expression. Now, what you need to notice is right here how we have the minus with right in front of this parenthesis. That is the same as saying negative 1 times 5d minus 5. So I'm going to rewrite it with that negative 1 inside, right? So we have our expression. It's the same thing, but instead of minus parentheses 5d minus 5, I have plus negative 1 times negative 5d, or 5d minus 5. So now from here, I can rewrite the first one with just 7 plus 3D. There's nothing to change there. Plus, I want to distribute that negative 1 to 5D, which would give me a negative 5D. Right? And when I go negative 1 times negative 5, negative times a negative is positive, and it would give me positive 5. Okay? So again, I want to combine my like terms. I have integers by themselves, and I have my variables, and the variable is D. 3D minus 5D would give me negative 2D. Plus, I have 7 plus 5, which is 12. Okay? It seems like a lot, but it's, you know, the way, obviously, the book has it broken down. Shows a lot, but really, we're just taking 7 plus 3D. And I'm not even going to do the plus. We're going to go minus 5D minus 5. I can rewrite it without the parentheses. Again, negative, I want to distribute, right? Negative times a positive would be negative. Negative times negative is positive. And then again, like I said, we just combine our like terms. Okay, so don't look too much into it. That's basically all we're doing when we're simplifying these expressions. Okay, now let's look at part C. So we want to factor 30x minus 5, and we want to find the greatest common factor, the GCF. So 30x minus 5. What is a number that goes into both 30 and 5 evenly? Well, 30 ends in a 0, so I know 5 goes into 30 and 5 goes into negative 5. Can't be anything bigger than 5, right? So I have 30x divided by 5, and I'll have my negative 5 divided by 5. Well, this one would give me 6x, and negative 5 divided by 5 would just give me negative 1. So when I go to rewrite this, I'm going to use the number, or my GCF, I'm going to write that here on the outside, which was 5. And then in the parentheses, I'm going to put what I had left, right? Which 30x divided by 5 is 6x. And negative 5 divided by 5 is negative 1. So it would be 6x minus 1. Of course, I know this is the answer because if I use distributive property, 5 times 6x would give me 30x. 5 times negative 1 would give me negative 5. I would get the same expression that we had in the beginning. Okay? Part D, expand negative 7 times, and we have in our parentheses 3x plus 1. So we're going to use distributive property. Okay, I want to multiply that negative 7 to 3x, and then I'm going to add it to what I get from multiplying negative 7 to positive 1. So I'm going to rewrite that down here. So I have negative 7 times 3x plus negative 7 times 1. Okay? Now when I multiply negative 7 times 3x, I will get negative 21x. Negative 7 times 1 gives me negative 7. So it would be minus 7 since they already have the minus sign there. Okay? So expanding is just doing the opposite of factoring. Okay? and vice versa. All right, everybody. So that's it for Module 7, Lesson 2. Okay, so hopefully you enjoyed it. Hopefully it was helpful to you. If you thought yes on either one of those or both, click like. All right, so that way I know. If you haven't done so already, please subscribe to the channel. That way you are getting notifications when the next videos are going out. Okay? Biggest thing for all my students, don't forget to complete and submit your work. All right? Every time, every assignment. So make sure you are staying on top of those things. If you are needing help, make sure you are getting that extra assistance. Okay? And as always, take care.